Good evening, my dear students. Today, I welcome you all for today's composite materials class. Today, I am going to discuss about polymer infiltration and pyrolysis process. So, today I am going to discuss about polymer infiltration and pyrolysis process to produce the ceramic matrix process. So, there are different infiltration techniques are there in to produce the ceramic matrix composites like polymer infiltration pyrolysis, and other process is the chemical vapor infiltration process, and other process is molten metal infiltration process, and other process is the sol-gel infiltration. These are the somewhat four important infiltration techniques. In today's class, I am going to discuss about the polymer infiltration and pyrolysis process to produce the ceramic matrix composite materials. Okay. Right. So this particular, I already mentioned that this is one of the like infiltration process, like polymer infiltration and pyrolysis process. There are four different types of infiltration techniques are there to produce the ceramic matrix composite materials. One of them is the polymer infiltration and pyrolysis process. So in this polymer infiltration and pyrolysis is like one of the important method to fabricate the ceramic matrix composite materials. Mainly, it involves the infiltration of polymer precursors into a fiber preform. Here, in most of this infiltration process that are related to produce the ceramic metal matrix composites, we are using some precursors. So, in this particular polymer infiltration and pyrolysis process, we are going to use the polymer precursors. Oh, so, and we are going to involving a polymer precursors into the fiber preform. So already we have to produce some material, and over that we are going to adding some rail like a matrix. So for that, whatever the fiber preform we produce, okay, over that we are adding the polymer precursors. So this will be followed. This polymer infiltration and pyrolysis will do it multiple times because appropriate amount of densified ceramic matrix composite have to produce. For that, okay, we have to perform this polymer infiltration pyrolysis multiple times. Okay, this process is somewhat particularly is useful in producing the ceramic materials, especially like silicon carbide and silicon nitride, such type of ceramic matrix we want to you know make it with the reinforcement. Then we can use this type of polymer infiltration and pyrolysis process. Especially we'll use polymer precursors to develop the ceramic materials like silicon carbide and silicon nitride. Okay, what are the steps in this particular polymer infiltration pyrolysis process? The first step is the first we have to produce the fiber preform. So this process mainly begins with the fabrication of the preform. Okay, so I already mentioned that we have to produce whatever the shape you require. Based on that, you have to produce the one fiber preform. So the fibers used in this preform are often the most probably you can use the carbon or silicon carbide, or you can use the aluminum fibers depending upon the properties. So most probably these are the mostly used fibers like carbon, silicon carbide, or aluminum fibers. These are the depending upon the requirements, you can choose appropriate fiber. Okay, the fibers may be woven or maybe stacked. Okay, maybe they can use some different thickness fabricated stacked sheets also can use, and these different sheets will glue it or stack it, one layer over the other. Such type of things also you can use. Okay, and different orientations also while you are uh, preparing the preform. You can change the direction and orientations of that particular fiber. This one while you are attaching or stacking the polymer this fibers. Okay, that is how you have to perform. And second step is the polymer infiltration. In this particular step, a liquid polymer precursors. We already mentioned that we are going to use some different polymer precursors we have to use. So such as one of the important mostly used is precursors, polymer precursors materials are like polycarboxylate or polysiloxane or polysiloxane. These are the mostly used precursor material like polycarbosylate or polysiloxane or polysiloxane. These are the mostly used polymer precursor material. These polymer precursor materials like for example, I am choosing polycarbosylate. So I have to infiltrate this polycarbosylate over the preform. So these polymers contains mainly elements like silicon, carbon, and nitrogen, which are very essential for forming the ceramic phases during the pyrolysis. Why we are choosing these only like precursors? Because these whatever the precursors we are choosing, for example, we are choosing the polycarbosylate. Why we are choosing this particular carbosylate? Because this particular polycarbosylate consists of elements, okay, silicon, and this particular one is very essential to develop that silicon related ceramic face. Thus for that purpose we are using this particular type of precursors material, polymer precursors material. Okay, so the infiltration process can be done under the vacuum, or we can use the pressure infiltration. Okay, we already discussed different infiltration, pressure infiltration or vacuum infiltration during the discussion of metal matrix composite product fabrication. So we can use such type of vacuum or pressure infiltration technique so to infiltrate that precursors for the fiber preform. Okay, so to avoid that no void formations or porosity, you can choose appropriate process that may be a vacuum or pressure assisted thing process you can use to infiltrate the polymer precursors for the preform. Okay, so already discussed that we can, based on the requirement, this we can use these are the mostly used by the different researchers uh, to as a precursor, polymer precursors. One of them is the polysiloxane. These can convert into silicon oxycarbide SiOC, and polycarbosylate used for forming silicon carbide. If I want to have the SiC as the ceramic matrix, then I can use the polycarbosylate, or I can, if I want like Si3 and 4, then I can use the polysiloxane for as the polymer precursor material based on the requirement. If I want silicon SiOC as the ceramics, then I can choose the polysiloxanes, or if I want silicon carbide, I can use as the polycarbosylane as the polymer precursors. If I want Si3 and 4 as the ceramic matrix, then I can use the polysilane. So like that, you can choose based on the requirement. You can choose the appropriate polymer precursor material. So after the infiltration, okay, the polymer precursor is cured. That is because we use some vacuum or pressure assisted technique. You are infiltrated the polymer precursors over the preform of fiber preform. After that, it should get hardened. For that, we are performing. We are making that entire that whatever the infiltrated object should be subjected to the curing. So this step mainly involves heating the material relatively to the temperatures around 150 to 300 degrees centigrade. Okay, to be why? Because we are maintain to why we have to heat this particular temperature is to cross link the polymer chains. We have to heat this particular no polymer preform infiltrated object to the temperature of 150 degrees to 300 degree centigrade, which will these cross linking of polymer chains, which increases the strength of the precursor before it undergoes the pyrolysis process. Okay. Next step is the pyrolysis. So after once it this particular the strength precursor chain formation is done. Okay, and after that we'll infiltrate that object will be subjected to the pyrolysis, where in the pyrolysis process the infiltrated the cured preform is subjected to the high temperatures, that is in the range of 800 degrees centigrade to the 1400 degrees centigrade. Okay, so in the inert atmosphere, such as like you can use nitrogen or argon gases. So during this heating condition in the inert atmosphere, this particular process is known as the pyrolysis. During this particular no, pyrolysis process, the polymer will be polymer decomposes and it converts into a ceramic material. So while you are maintaining this temperatures in the range of 800 to 1400 degrees range in the inert atmosphere, then the polymer precursor is decomposes and it converts into the ceramic materials, like it will convert into SiC or SiOC or Si3 and 4 depending upon the what type of precursor you used. Okay, like after that the polymer is transformed entire, like you maintain the temperature for certain duration, certain time. Due to that the polymer is transformed into the ceramic phase, and sometimes some shrinkage and formation, some you can even like, because during that process there may be shrinkage and formation of pores may occur, which reduces the density of the material. Okay, that may happen actually. And because I already mentioned that there may be a, some pores may develop, or some improper densification may happen. Okay, due to that again we already mentioned that we have to perform that infiltration and polymer infiltration pyrolysis process as a multiple cycle. That's why to our to make that no, to reduce that porosities, and to avoid that shrinkage, this one we will perform the this particular pyrolysis process or infiltration as a multiple cycles. Okay, most probably to get the densified ceramic matrix composite material through this particular polymer you know infiltration pyrolysis process, minimum of 4 to 8 cycles are required. So minimum 4 and maximum of 8 cycles are required to produce the densified object. Okay, with the desired mechanical properties if you want, then definitely we have to perform this infiltration pyrolysis process for 4 to 8 cycles. Okay, after that performing several cycles of this particular infiltration and pyrolysis process, the will, based on the thickness and other this one, will produce the desired CMC object with the desired density and properties. This is the final product that we can obtain after the multiple cycles of performance of the infiltration and no, that particular pyrolysis process. Okay, this is the how you can see the different no, steps in this particular no, polymer infiltration and pyrolysis process. You can see that first we have to prepare the ceramic fiber preform. Okay, so after that we are infiltrating the polymer precursor. Okay, whatever the chosen polymer precursor, that we are infiltrating by means of the vacuum or some pressure assisted technique. We are infiltrating over this particular fiber preform, and after that no, we are performing some curing operation. We are heating, and we are making that polymer precursor, that fiber should be get hardened. For that we are maintaining the we are heating up to the 300 degrees centigrade, and after that we are performing the pyrolysis process, that we are increasing the temperature up to the in the range of 800 to 1300. Why? Because due to at these high temperatures, that polymer precursors will be decomposed and it will develop the ceramic matrix. For that reason, we are no, performing this pyrolysis process. These are the important steps. Okay, and after that again you can see that this particular cycle, because again we have to perform the like this particular infiltration, because this like I already mentioned that we required some 4 to 8 or 4 to 10 times depending on the requirements. Okay, what is the like object shape and dimensions all, and whether we are avoiding the shrinkage and porosity pores we are eliminating. Till then you have to perform the this infiltration and pyrolysis process. This is how the process is going to work. Okay, pyrolysis, like polymer infiltration and pyrolysis process. Okay, coming to the advantages. Okay, the advantage is these PIP CMCs, they will have the relatively low processing temperatures when compared to the chemical vapor infiltration. Okay, when compared to the chemical vapor infiltration process, these particular polymer infiltration pyrolysis process requires the lower processing temperature. That is the advantage, because whenever you are using the lower temperature, the consumption of energy will be less. Okay, and also that if you are maintaining low temperatures, they won't if you are increasing more amount of high amount of temperature, it may damage the fibers. Such things you can avoid if you are using the PIP process, because when comparing with the chemical vapor infiltration process, the here we are going to use some low processing temperatures. And also the second advantage is the versatility in ceramic matrix composition. We can choose the different polymer precursors material depending upon whether we have to produce silicon carbide or Si3N4 or SiOC. What type of matrix you require, based on that we can choose appropriate no, polymer precursor we can choose. And also by using this particular PIP, like a polymer infiltration and pyrolysis process, we can produce complex shapes also can produce by using this particular polymer infiltration and pyrolysis process. And when compared to the chemical vapor infiltration, the cost of this particular equipment and processing is very less when compared to the chemical vapor infiltration process. And it also have the advantage, that is there should be good fiber and matrix bond, because where during the pyrolysis process there is a decomposition of the ceramic, that is there is the decomposition of polymer precursor is going to happen. And due to that, proper polymer linkages will happen with the matrix material. That's why there is a good bonding between the fiber and matrix may happen either by using this particular polymer infiltration and pyrolysis process. And coming to the limitations, even after multiple times, that is, it will subject it to the porosity. So that is the even perform 4 to 6 or 8 cycles. Sometimes it may even can some residual porosity may remain in the ceramic matrix. That is the disadvantage. And it is because this PAV process where you are using some 4 cycles, 4 times or 6 times or 8 times or 10 times, you are producing infiltration and pyrolysis process multiple times you are performing to achieve the densified objects. Due to that, it will take a high amount of time. That is a time consuming process. That is the limitation. And either already you've seen that the conversion of polymer into a ceramic during the pyrolysis process. We already mentioned that while pyrolysis we are heating the temperature to the higher temperatures, due to that it may have some shrinkages may undergo. That is the disadvantages related to this particular process. And temperature limitations. While the PIP process can operate at relatively lower temperatures, So the final ceramic materials may have some limitation in terms of the operating temperature, particularly when compared to the CMCs. The like, because the temperature operating temperatures are somewhat very less temperature and many. That's why only it is this particular process is only suitable for certain like objects only, like certain precursor materials only. You can this particular process is suitable. Okay, that's why due to the temperature limitations, we can this particular process is only limited to few materials only. That's why that is the one of the limitations. So that's it, my students, my dear students. So today I explained about the like polymer infiltration and pyrolysis process. So mainly in the polymer infiltration and pyrolysis process, first we have to produce one fiber preform, and over that we are using some, we are infiltrating like precursors, polymer precursors, and after that we are performing the pyrolysis process. During the pyrolysis process, the polymer precursors will be decomposed, and it will develop the like SiC or other different matrix, ceramic matrix within the local region. That is how this particular polymer like infiltration and pyrolysis is going to work. This particular polymer infiltration and pyrolysis process is only suited for certain materials only due to the temperature limitations. That's it for today. Thank you. Thank you again.